first of all, what's f of x plus h equal to? Well, to find that, we just take our function f of x equals x squared, but instead of evaluating at x, we evaluate that function at x plus h. So f of x plus h, we just plug x plus h right here for x, and so we would get x plus h squared. And let's go ahead and FOIL that out and expand that binomial. So then we would get x squared plus 2 times x times h plus h squared. Remember this formula for expanding perfect square binomials? So that's what I just used to expand this. Of course, you could FOIL it, but it's better to memorize the formula and use the formula because it's faster. Okay, so now we figured out what f of x plus h equals. So now let's take that and plug it in to the formula right here. And we already know what f of x is. F of x is x squared, so we can take x squared and plug it in for f of x. So when we substitute those things in, we'll get this, and now let's simplify this top part. We can drop the parentheses to get this, and now we'll see that we have x squared minus x squared, so those terms will go away. And we'll be left with 2xh plus h squared, all divided by h. Now we see that in the top, we have this common factor of h in each term, so let's factor out an h. So if we factor out an h, we can rewrite this as h on the outside times 2x plus h, and then still all divided by h. Now we see we have this common factor of h on the top and bottom, so we can cancel that common factor, and all we're left with is 2x plus h. So now this is the simplified form of the difference. Okay, let's find the simplified form of the difference quotient. This time our function is 1 over x. Okay, so we know this is our difference quotient. We just need to figure out what f of x plus h is, what f of x is, which we already know f of x is 1 over x. Plug those values in, and then we can start simplifying. So first, let's find f of x plus h. To find f of x plus h, you just take x plus h and plug it in to this function. So you just plug it into the x right there. So then that would just equal 1 over x plus h. I've just replaced the x with x plus h. And we can't really simplify that at all, so that's what we're going to take and plug in right here into our difference quotient. And then I'm also going to take 1 over x and plug it in for f of x. Okay, so now I've plugged both of those things into my difference quotient. Now I have this. This is kind of a complicated expression because we have lots of fractions going on. So we just got to be careful that we apply all the algebraic rules correctly in order to simplify this correctly. So the first thing we want to do is get one single fraction up here in the numerator. To do that, we're going to have to get common denominators between these two fractions. To find common denominators, remember you have to find the LCD. So the LCD in this case will be x times x plus h. So we just need to proceed to get the LCD in both denominators. For the first denominator, all we're missing is the x. So we need to multiply top and bottom by x. In the second fraction, we're missing the x plus h factor. So we need to multiply top and bottom by x plus h. Now we can just multiply fractions, and we get these two fractions now. And they both have the same denominator, so now we can subtract these two fractions. And so we get this. So remember, when you're subtracting fractions, all you do is subtract the numerators from each other, which I've done here, and then you just keep that one common denominator, which you can see I've done that here. Now, because we're subtracting fractions, it's very important that I put parentheses around this x plus h. It's a very common mistake to have just written this as x minus x plus h and forget those parentheses. So that would be a mistake. And in which case, if you did that, you would just end up with h. But as you can see, we should end up with negative h here because this negative sign will be distributed to x and to the h. So just be careful, make sure you include those parentheses. Okay, so proceeding down here, I distribute the negative sign like I said, and I'll get this, and then I have x minus x, so that cancels, so I'll get this. So now I finally have one single fraction up here, and then I'm dividing by something down here. So in that case, remember, if you're dividing fractions, you use the keep, change, flip rule, or skip, flip, multiply. So we keep the first fraction, and then we multiply by the reciprocal of the second fraction. In the second fraction, because it's just h in the denominator down here, I can write it as h over 1 if you want to, so you can see it clearly as a fraction. So you can see now I've taken the first fraction and multiplied it by the reciprocal of the second fraction. Keep, change, flip. Now these h's will cancel, and so I'll just be left with negative 1 over x times x plus h. And so this is our answer. This is our simplified differential